Hi everyone, this is Algebra 2, and we're looking at Chapter 5.5 and 5.6 all in the same video. So the video is going to be kind of long. The objective is not to watch it all in one sitting. You can kind of split it up over the course of a couple days or a few days, or watch the first 10 minutes, take a break, watch the next 10 minutes, etc., etc. Okay, so what we're going to be looking at is evaluating a cube root function. So we're continuing our understanding of how functions work and how to solve them. So looking at number 1 here, we have f of x equals the cubed root of x plus 3. All we need to do here is take this 64, f of 64, and we just need to plug it in for x, which you all have done many, many, many times. So we're going to have, and I'm going to use blue here, we're going to have 3, or the cubed root of 64, and on the outside plus 3. The cubed root of 64 is 4. And then plus 3, so our answer is 7, okay? Answer is 7. And let's do that. Okay, next one, same thing here. We have a negative, and that is fine. Again, we could deal with negatives as long as it's a cubed root. And so we have the cubed root of negative 125. On the outside plus 3. The cubed root of 125, or negative 125 rather, is negative 5 plus 3. So my solution's negative 2. Make that negative 2 a little bit bigger to see. Okay. And then lastly, we have 1 here. We just need to do the cubed root of 1 plus 3. The cubed root of 1 is just 1. Plus 3, so my solution is 4. All right, go ahead and do B and C on your own. It's the same idea, just be careful in the steps that you're utilizing, because the difference here is that you have everything under your cubed root, whereas here you have things under your cubed root, but you also have an external property out there of negative 1 or minus 1. Okay, number 2 here says graphing a cubed root function. So what we're going to do here is you have your radicand under there. And let's do this. Let's write here at the top, just kind of draw an arrow, x equals 0. And so what we want to do is start at x equals 0, and then find 2 points to the right or 2 points to the left. So I'm going to put 2 points to left and 2 points to the right. And as always, forgive my penmanship. I'm trying to write fast so that these videos can go quicker. So we want to start at 0, right? X equals 0, and that point is there. Well, I want to choose 2 points to the right and 2 points to the left. Well, if you look at what's going on here, we have the function f of x equals cubed root. Remember, we're looking at cubed root. So it would be best to find points that you can utilize the cubed root with. 0, 1, 8, 27, etc. Obviously, this does not go to 27, so I don't want to do that. But let's go ahead and draw a t-table here. And then, And then what I want to do is have my f of x on the top. And on the left-hand side, I'm going to choose two values to the right and 2 values to the left. So 0, 1, 8, negative 1, and then a negative 8. So I start at 0. That was given. So I'm going to plug 0 in for x. Oops. Row x, that should be 0. The cubed root of 0 is just 0, and that's where I got this point right here, 0, 0. Then I'm going to do the cubed root of 1. Okay, cubed root of 1. That's 1. I'm going to do the cubed root of 8. That's 2. The cubed root of negative 1 is negative 1. And then the cubed root of negative 8 is negative 2. So let's go ahead and graph these points. I already have 0, 0. Next one is 1, 1. then 8 comma 2, then it's -1 comma -1. I'm going fast here because this is from Algebra 1 and Algebra 2. We've already graphed coordinates already. -8, -2 is right. Oop, forgive me. That's on the x-axis. -8, -2 is right here. And all you need to do is connect the dots here. Okay. It creates almost like an S shape. And it's important to remember what this looks like. Okay, because this line, this cubed root function, when graphing it, goes right through the origin. The reason why you want to know what this looks like is because when you're translating later on, it's going to be helpful to just already have this memorized or known where these coordinates are or lie, because then you could just move each point up, down, left, right, and you don't have to do all this math over here. It will save you a ton of time. Again, it will save you a ton of time. Go ahead and do B the same way you did over here. Okay, there's a shortcut to this, which I'm going to show in the next step, but start with choosing the values for cubed root. So be very careful on how you do this because you want to use cube root values. But there also is a shortcut that if you just graph this line right here and you use this to translate it right, then you automatically have it. We'll cover that in class, but I want you to struggle a little bit here on trying to solve it. Okay, letter C. Well, as stated previously, if I just plot that original graph or cubed root that I did that crossed the origin, then I could just translate it. So I'm going to write some steps here. And I'm going to write plot original points. Let me make that cleaner. Points for f of x equals the cubed root of x. So I'm going to plot that right now, just so we could see what's going on here. So I'm going to have the point at 0, 0. The other points were right here. And then I had 8, 2. And then I had 8, -2. And so again, I just memorized those. That's how I'm able to do this so fast. I'm not looking at anything. So let's just kind of do a dashed line here. Doesn't have to be perfect. The coordinates do, but the line can be kind of messy. Okay, now the second part we want to do, and I'm going to put this in blue. This is the shortcut. We want to translate, my pen's not working on me. We want to translate, basically just move, these points to the specified amounts. This is where h comma k. If you don't remember h comma k, there are videos from chapter 2 that goes over h comma k, but we also looked at it in 5.4. So I'm zooming in on this +2 right here, and I want to switch it. This is my h. And so what this is saying is really 2 units to the left. Okay? So if I just move every point on here 2 units to the left, then I'm done. I don't have to do that crazy t-table, choose values and plug them in. It's very, very easy. So 1, 2, there's that point. 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 And 1, 2, there's that point. And now we have our new cubed root function that has been translated. And so that's it. If you could do that, you're pretty much golden. Now on this one, a little trick here. Again, you want to do the same thing. You're going to want to plot this original cubed root function. And then if you notice on the outside, this is your k. I'm not going to tell you which direction to move it, but this is your k. All right? So try to graph these next 3. This one's your k as well. This is your h. My pen is really not working for this video right now. This is your, well, here, let's just do this. This is your h. This is your k, or excuse me, wow. This is your k, forgive me, and this is your h, comma k. Alrighty, there we go. Okay, so now that we have those listed out, now we have 5.6 here. So this is actually really easy, and there's a little bit of tricks that can happen with this, but we're introduction to solving a radical equation. So if you recall, our index here is really 2, right? So with that in mind, to get rid of this square root sign, or the radical, all we need to do here is one step. If you make everything to the power of 2, it will remove that square root sign. And remember, an equation sign is basically a balancing beam. Whatever I do on the left, I have to do on the right. So I'll make that a power of 2. So what happens here, y equals 6 to the power of 2. So I have y equals 36. And we've talked about this before. It's not anything new that to remove this, you put something to the power of 2. We've been doing that for a few units now. So we're going to do the same thing on b over here. I see that this is the square root of y. To get rid of that square root sign, you want to make it to the power of 2. Whatever I do to one side, I have to do to the other. So that removes that square root, and I have y equals 9 squared, or 9 to the power of 2, and that equals 81. Okay? So go ahead and do the other ones on your own, and you should be successful in solving those. Okay, so we have the inverse operation of taking the square root is taking the square. All right? What are some other examples of inverse operations? I think it would be helpful to add these in your notes. Students tend to still struggle with this. If I have addition, then the inverse of addition is subtraction. If I have multiplication, then the inverse of multiplication is division. And lastly, if I have, say, a cubed root, then what's the inverse of the cubed root? Or what's the inverse operation? X to the power of 3. And it is vital that you understand those components because they are operations that take place within mathematics, and you'll need to utilize those, or you can utilize those in solving for equations. So here we have solving a radical equation that simplifies to a linear equation, one radical, and this is basic, meaning this is as simple as it gets. So if you recall, I have a square root sign right here. I want to get rid of that. You should be thinking, oh, I need to do power of 2 to do that. So that gets rid of the square root sign, and that's what I'm left with. And you know what? I'm going to simplify that 6 squared. I'm going to go directly to 36 here. And then we just minus 7 to both sides, right? Something we've been doing for a while. We get x equals 29. And that's it. Now you're going to do b on your own because we did one very similar to that. But I don't want you to get hung up here. All right? So let's do c together. I have this square root, and then I have 2 whole numbers that are like terms. Now, some of you are going to go, oh, well, I could just square root that and square root that. Well, before we do that, let's get rid of this 3. And now I have the square root of x. I have the square root of x equals 6. 9 minus 3 is 6. And now to get rid of that square root sign, I just square both sides. And now I have x equals 36, and we're done. So there's a little bit of a step to do beforehand. And I cannot draw a square. There we go. And that's going to be our solution. Now, we're going to do the same idea here for number 3A, because there's both radical equations taking place, and we don't do anything different here. I want to get rid of these square roots. To do that, we're just going to do the power of 2 to both sides. And what that does, it just removes that sign for us. That's all we want. Okay, it just removes the sign. And now I'm left with this equation, and I want to solve for w. And this gives a callback to Algebra 1 in the beginning of Algebra 2. You could start with whatever you want to start with. You're just going to combine like terms. I'm going to get rid of this 1 first. Again, you could deal with the w's if you want right off the bat, but I'm going to do that second. Gives me 4w, what is that, plus 8. Now I'm going to deal with my w's. So minus 4w. What does that leave me with? That leaves me with 4w equals 8. I need to divide by 4. Now, actually, I want to pause for a second. Some are still getting confused with this 4w on what to do. This is saying 4 times w. I want to take the inverse operation of that, and that's where this comes into play. If I'm multiplying right here, the inverse of multiplication is division. Hence why, and we've talked about this in the past, hence why I divide both sides. So w equals 2. Okay? W equals 2. Go ahead and try letter B on your own. It's the same exact steps. You're just squaring both sides and solving for y. Number 4 here, a little bit different, not too much different. We're kind of expanding on things. This is why we're adding in a quadratic equation into the mix here. Now we're going to start off here by squaring both sides because I want to get rid of the square root sign or the radical. That leaves me with w squared equals 8w minus 12. Let's go ahead and move everything over to the left-hand side, which will leave me with w squared minus 8w plus 12 equals 0. And folks, we are back again at factoring. Lucky all of you. So let's put in factor here. And so we'll have our x. And at this point, you really should have it memorized. We have done this for months and months. Your c goes on top, okay? That's going to be 12, negative 8. You want to find two numbers that multiply to get you to 12, but when you add those same two numbers together, that gives you negative 8. If I do negative 6 and 2, it works out great. We'll have w minus 6, w minus 2 equals 0. And what you want to do from here, if you recall, because this is all review now at this point, you want to set them both equal to 0. W minus 2 equals 0. Thus, our w, let me make that cleaner, our w equals 6 and 2. Perfect. Just when we thought factoring was maybe done, it comes back again. You're going to do letter B on your own. It's going to be solved in the same exact manner, and we'll cover it in class if you have any questions. So now we get into something a little bit unique here. This is algebraic symbol manipulation with radicals. So I'm actually going to do all of these together, but because it can be kind of difficult. So the first step here, it's asking us to solve for the letter D. Well, if you look at something, I have this all under the square root. Whenever you see that, you should automatically be thinking, okay, that's fine. I can get rid of that. I need to take it to the power of 2 on both sides. So you have u squared equals d over 3. And this is where you need to know your inverse of operations. If I have division taking place here, and I need to solve for the letter D, what's the opposite of division? It's multiplication. So whatever I do to one side, I have to do the other. The great thing about that is those 3's go, and what you're left with here, and I'm going to kind of reverse some things, but our answer is D equals 3u squared. I just flipped everything. Okay. Again, right here, 3 times u over 1 is 3u squared. They're not like terms, so you can't combine anything. All right, letter B then. Same kind of idea that's happening here, but I want to solve for w. meaning I want to look at what's happening here on this equation, and I want to get my 9 over here, and that way I'm almost isolating my w. Well, that's 9 times, again, 9 times the square root of w. I want to take the inverse operation, that's division. Whatever I do to one side, I have to do to the other. That gives me f over 9 equals the square root of w. And if you recall, to get rid of that, you square both sides. And I'm going kind of fast because we're utilizing operations that we've already learned. We've already learned that you take the power of 2 to both sides. And so we're just applying those concepts together. And if ever I'm going too fast, take YouTube, slow it down a little bit to 0.75 or 0.5 if you need to, or pause it and replay it again. And it's there for as much as you need. So now really what's happening here, if you remember from your properties of exponents, you need to bring that 2 to each term. You'll get f to the power of 2 over 9 to the power of 2. Again, we learned operations of exponents. And then, or exponent rules, however you want to phrase it, equals w. We're not done yet, though. We want to simplify this, okay? So we'll have w equals f squared over 81, and that is our solution. F squared over 81 is our solution. Okay, letter C here. We want to solve for e. Well, I need to be able to isolate this e, so I need to get rid of this square root sign. So you should be thinking, I got a square, or square, I keep saying square. You want to create it to the power of 2. W to the power of 2. And this is going to get rid of the square root sign. If I have 3 times e here, okay, we're solving for e. What's the opposite of multiplication? In your head, you should have said division. So my answer is e equals w to the power of 2 over 3. All right, we're moving along. R here. So I first need to deal with this 6, right? Because we're trying to solve for r here. Well, if it's divided by, what is the inverse operation of division? You should be thinking multiplication. So let's get rid of that 6 by multiplying 6 over 1. Whatever I do to one side, I must do to the other. That leaves us with 6u equals the square root of r. You should be thinking, I can get rid of that square root sign. So now what do we have? We have to take that, I'll do it in purple, that 2 and bring it to each term. So that leaves me with 36u squared equals r. I'm just going to flip it just for the sake of putting down the answer. That really is r equals 36 u squared. And I want to make it cleaner. It's not much cleaner, but it looks a little bit better. Okay. So again, I know I keep repeating myself. We're just taking operations that we learned in prior units and applying them to what we're learning here with dealing with square roots, cubed roots, or algebraic symbols and manipulating with radicals. Alrighty, we have a word problem. Isn't that all your favorite? I know in school I hated word problems, but this is really just a repeat topic from 5.4, and that's what we have listed here. So if you knew how to solve 5.4 word problem, this one is not actually very hard at all. So it says in an object, or if an object is dropped from a height of h meters and hits the ground in t seconds, then they give us an equation right here. Suppose an object is dropped from the top of a building that is, and it gives us the list of meters, tall. How long does it take to hit the ground? So we're trying to figure out our time. So we're going to have to utilize this. We can highlight this over here, this equation. Let's write that equation down. So t equals the square root of h over 4.9. Well, it told us what h was, and that's the other one I have highlighted. It said, suppose that an object is dropped from the top of a building, and it gives us the height of what is taking place here, tall. So I know my h equals 446.88 meters. All right. Well, if I know what h equals, this right here, I can plug that in for h and then just solve. Again, this is exactly what we did in 5.4. So I have the square root of h, which is 446.8, all over my 4.9. Excuse me. And I'm going to do that in my calculator. I'll get the square root of 91.2. And you'll have to do probably some rounding here. That comes out to 9.5 seconds. Units do matter. Again, units do matter. So we'll just box that. Okay. So number 6. All right, we're almost done here. One more page. Well, I'm almost done. You got a lot to do on your own. But solving an equation with a root index greater than 2, problem type 1. So meaning our roots are going to be everything basically greater than 2. So it's going to be like 3, 4, 5, etc., etc. So we're going to do this the exact same way as to what we've done before. To get rid of that cubed root, I'm going to do to the power of 3 to both sides. And as you can see, this isn't hard. That gets rid of that cubed root. That just leaves me with u 2 to the power of 3. So u equals 8. And that's it. We're done. I think you all are capable of memorizing all that. You're going to do B on your own. It's solved the exact same way. Letter C, I have 4. So I want to get rid of this. So if I raise it to the power of 4 to both sides, we are left with w equals 3 to the 4th power. So w equals, if you did that in your calculator, you get 81. Okay. This one I'll do with you. I think it will set up for the other ones. So we need to get rid of this 3 first. So we need a minus 3 to both sides. The reason why we minus is because if we're adding 3, meaning if this is plus 3, the inverse operation of that is minus 3 or minus. That leaves us with equals 4 minus 3 is 1. I want to get rid of the root 5. Oops. So if I go to the 5th power on everything, 1 to the 5th power, guys, is just 1. So that's what we have there. And you should be well off in solving B, E, and F by yourself. So we have 8 here, solving the equation with a root index greater than 2, problem type 2. So exact same thing we just did. It's just a little bit of a harder problem. What I notice right off the bat here is this 3 is hanging outside of this cubed root. So I want to get this 3 over here. So let's just eliminate that right now. So minus 3, minus 3. And that's going to cancel. So let's bring down our cubed root here. What is that? 6w. 6w. Oops, I put 64. 6w plus 4 equals 4. I want to get rid of that cubed root. You should automatically be thinking you need to put it to the power of 3. That gets rid of the cubed root, so I'm just left with 6w plus 4 equals 4 to the 3rd power. That is 6w plus 4. 4 to the 3rd power is 64. And now we just solve everything that we have been in the past. So we're going to solve for w. 6w equals 60. You're multiplying, so you need to divide by 6, which is the inverse operation. W equals 10. Now again, if that was too fast, just slow the video down, pause it, watch it again. It doesn't hurt to watch these things more than once. Matter of fact, it's extremely helpful that you do that because as math teachers, we don't expect you to get this the first time. That's why there's mathematical skills and practice involved. So go ahead and practice letter B on your own. If you're confused on how to solve it, rewind the video, watch how to do it, and then apply it to letter B. Okay, solving an equation with an exponent 1 over a, problem type 1. All right, so these aren't too bad. We're just going to apply basically what we did last class. So it's a little bit of 5.3, I believe, and we're going to apply it here to 5.6. So if you notice something, you have u to the power of 1 over 3. If you remember, that 3 right there is our index. So really what's happening here is I'm going to have the cubed root of u equals 4, right? That's what this is saying. Okay, we took exponent form and we turned it to radical form. Well, we just learned how to get rid of that cubed root. Okay? So what I'm left with here is just u 4 to the third power. Actually, I don't even need those parentheses there anymore. 4 to the third power, and what does that give me? What is 4 to the third power? That is u equals 64. So let me kind of backtrack here if that was too fast. What we have going on, you have u 1 to the third power, or 1 over 3, or to the power of 1 over 3, equals 4. I translated this into being my index of 3 over, or should I say over, to the square root or cubed root of u, getting my roots mixed up. Well, we learned that in 5.3, I believe. Well, if I take to the power of 3, that gets rid of that cubed root, and that's what we learned during this course, this class for 5.5, 5.6, and you go ahead and solve. So it is vital that you do that. Go ahead and try this one. You have your index again, and then you're going to use the same idea that we used in the prior examples above. Okay, this one's not any different. It's just a problem type 2, so they're just trying to make our lives a little bit more difficult here. So what I want to do is I already noticed right now that this 2 is hanging outside. I want to get rid of that. So let's move that over. That's going to cancel, so now I'm left with 2u minus 14 to the power of 1/3 equals negative 2. Well, all we need to do here is this really has a cubed root, right? Because my denominator is 3. So if I have the index of 3, then I can just make this look a little bit different here. 2u minus 14 equals negative 2. Now to get rid of this cubed root, what do we got to do, guys? Yes, to the power of 3 to both sides. Good job. And you have 2u minus 14 equals negative 2 to the third power. 2u minus 14 equals negative 8. Let's add 14 to both sides. 2u equals, what's negative 8 plus 14? 6. Divide by 2, u equals 3. Okay. Now, how you're going to get good at these problems is trying them on your own. The expectation is maybe you don't get it the first time. Maybe it's going to take a couple times to get these skills down and to remember how to do everything. But that is the conclusion of 5.5 and 5.6. Thank you, everyone, for your time, and take care.